Okay, it's recording.
So at the beginning of the season, we built a robot that was like a prototype that we named AlphaBot. And this allowed us to test the flow of the game because we hadn't seen how it would play out beforehand. And it also let us get some driver practice before we had the finished robot all together. And then the other things we did in the first couple of weeks were do a lot of intake prototyping. Since the game pieces are different every year, the intake is something that needs to change the most between year to year. So we tested different intakes that included like rollers and claws. Eventually we landed on a roller type intake, but the first one we built was a bit too heavy. So for one last prototype, we built a more refined laser cut version of a roller intake that used the same rollers that we had that we were going to use in the final robot, because we found that those worked the best with the game pieces this year. And because we had the laser that we had just gotten like maybe a month prior, it allowed us to prototype this incredibly fast.
Early on, we knew that this robot was going to be a new challenge. We'd never built something like this before. That is an arm that could also extend. It's a whole new degree of freedom. The closest thing we'd built at this point was probably Outlaw, which did have an arm with a very high moment of inertia, but it could not extend, and it was a much slower mechanism overall compared to Sidewinder. In addition, we knew that because the arm could extend a lot faster than it can rotate, we were going to have to be really smart about how we controlled it, because if we extended too fast, it would cause us a lot of issues, such as increased moment of inertia and just being very risky as far as getting hit or drawing penalties. The way that we solved this was by designing our own control system on a whiteboard discussion between a couple of the programmers, and what we ended up settling on was linking the position of the extension to the position of the shoulder and relating them using a power function such that most of the extension of the arm would only happen towards the end of the motion.
So one of the first things we had to change after we had the entire robot together and the first iteration was done was the intake, because the first intake was not able to pick up cones from the ground. The new intake was designed with that in mind, and it allowed us to pick up cones from the ground, as well as it reduced a lot of the size. This is more or less what the final intake looked like, but it still had a lot of way to go. The other thing we found out was that the tube on the intake that we were using was far too brittle. So after doing some testing, we found polycarb tube that was round would be a better choice. So we had to adapt the intake in later iterations to accommodate the round tube.
After our first competition, where despite seeding first, we got knocked out in semifinals, which is a disappointing result for us. We knew we had to make some changes. So there were a few big issues. The first was our auto, which consisted of us only scoring a low cone and then going to balance. And the second large one was our difficulty placing high cones. We knew that auto was going to be a big deal, especially coming into our second event. Everyone's auto would be at a higher level. We figured out we could actually score over the back of the robot as opposed to forwards, with the caveat that it made us incredibly unstable, which wasn't an issue when our bumpers were braced against the grid. So in auto, for our first element, we could just score behind ourselves and we would avoid needing to turn around. This allowed us to let us save a lot of time. One of the other strategies that we had seen some, I believe, California teams do early on, we called bowling. We realized that we could launch cubes just with the inertia of our robot by just driving into the community and ejecting cubes while moving. And this allowed us to score the hybrid significantly faster. I believe in some practice runs, we managed to hit like 15 or 16 elements just because it was so fast. And these two changes were very beneficial to us.
The robot was mechanically complete after the first competition, but it still had a lot more to go in minor tweaks for tuning to get it to the final competition level that we wanted. So some of those include, we added an encoder on the elevator to get more precise position information on the extension. We also changed the wrist from a plastic 3D print to a more sturdy metal piece, because it's a pretty important part on a robot and it was failing in our first competition. And we needed further tuning on the intake roller spacing to make pickup more effective. So by the end, when we got to Worlds, it was like top shape.